Tesla has long been the gold standard in battery innovation, dominating the game with unmatched capacity and efficiency, but now, a bold new contender has arrived, turning Tesla's much-anticipated Cybercell into yesterday's news. This revolutionary battery isn't just more efficient, it's a dawis sandir brine, or dawi kizani dawis daw, and dawi brigramoy. It dawi diridite, pompewa brine, pawig diri, aggewi kai, bertawiix, packs more power, boasts a larger capacity, and redefines practical usability. Curious about what Tesla is up against? Let's dive into the groundbreaking battery technology that's shaking up the EV world and leaving Tesla in the dust. Enjoying the content? Don't forget to hit the subscribe button and turn on notifications so you never miss out on our latest updates. So, who is QuantumScape, the genius behind this seismic shift? Meet QuantumScape, the Silicon Valley trailblazer that's giving Tesla a serious run for its money. Founded in 2010 by Jagdeep Singh, Tim Holm and Fritz Prince, this company started as a scrappy little startup. That all changed in 2012 when Volkswagen, one of the world's biggest car manufacturers, took notice and teamed up with them, providing substantial funding. And it didn't stop there. Even Bill Gates saw the promise in QuantumScape and backed them with his own investment dollars. QuantumScape hit the headlines in 2020 when they revealed they were working on a game-changing battery that would leave conventional lithium-ion batteries in the dust. The buzz was immediate and global, with investors lining up to pour more money into the venture. But this raises a big question. What exactly is this revolutionary battery technology everyone's talking about? The answer: QuantumScape's cutting-edge solid-state batteries. Think of solid-state batteries as the next big leap in EV power. For years, solid-state batteries have been hailed as the future of electric vehicles, and for good reason. They share some similarities with traditional lithium-ion batteries. They're lithium-based too, but with a groundbreaking twist. Instead of using liquid or gel electrolytes like their predecessors, solid-state batteries rely on solid electrolytes, often made of polymers or ceramics. While this might seem like a small tweak, it's actually a game-changer, delivering massive improvements in performance and utility. First, due to their much higher energy density, solid-state batteries have far greater capacity. This means they allow for a much longer range, while being lighter and more compact. Cars equipped with these batteries will be more efficient and easier to drive because of their lower curb weight, and, less overburdened by excessive mass. Essentially, this means we'll finally get range-efficient vehicles that aren't unnecessarily overpowered, leading to a considerably lower price tag for electric vehicles in the future. What's even more interesting is that, despite being lighter, solid-state batteries allow for higher power output than regular lithium-ion batteries, meaning vehicles can achieve even faster acceleration. The cherry on top is that solid-state batteries have a higher voltage tolerance, resulting in much faster charging times than standard lithium-ion batteries. This directly addresses one of the biggest drawbacks of electric vehicles compared to internal combustion engine cars. But the biggest reason why they're superior to lithium-ion batteries is their stability. The primary concern with regular batteries is how easily combustible they are. Traditional lithium-ion battery cells combine a flammable electrolyte with a significant amount of stored energy. Once a cell starts generating more heat than it can effectively disperse, it becomes highly susceptible to thermal runaway, a process where excessive heat can cause short-circuiting, mechanical damage, or even spontaneous combustion. On the flip side, solid-state batteries are considerably more stable. Since they lack flammable or toxic gases and contain no volatile liquid electrolytes, they're far less prone to ignition or explosion. What's incredibly interesting is that solid-state batteries have existed as a concept for almost 2 centuries. Michael Faraday was the first person to discover solid electrolytes back in the early 1830s, laying the foundation for all future development in solid-state ionics. However, these batteries were long known for their short lifespan due to rapid depletion of solid electrolytes. Despite this flaw, they remained a potent concept for the future, and QuantumScape seems to have Tesla in a tight spot with their strides in pioneering solid-state battery technology. It's only a matter of time before other manufacturers jump on the bandwagon, potentially leading to Tesla's Cybercell facing an early retirement. So, this raises the big question: can Tesla catch up to QuantumScape? Let's start with the basics. Tesla is a giant in the industry, a well-oiled machine with immense production capabilities that go far beyond just research and development. Unlike QuantumScape, which is still classified as a startup focusing solely on battery R&D, Tesla has already proven itself with groundbreaking products that have reshaped the EV landscape. On top of that, Tesla has the resources and strategy to outmaneuver competition, including acquiring startups that could fast-track their quest for the ultimate EV battery. If QuantumScape proves its worth, there's nothing stopping Tesla from snapping it up. However, here's the catch: QuantumScape's work is still shrouded in mystery. Despite all the hype, they've yet to show tangible results to back their lofty claims. This secrecy has led to skepticism, and in 2020, the company was even accused of fraud. Hedge fund Scorpion Capital labeled QuantumScape a pump-and-dump scheme after the startup secured over $1 billion in funding without delivering any concrete proof of its battery technology. The lack of a viable product has fueled doubts about their legitimacy. That said, change may be just around the corner. QuantumScape recently announced they're gearing up for mass production. Their factory is reportedly under construction and expected to be operational by 2025. If everything proceeds according to their ambitious roadmap, the successful commercialization of QuantumScape's solid-state batteries could silence skeptics once and for all, revealing whether the company's technology represents a genuine revolutionary leap forward or remains, aspirational wishful thinking. Such a moment wouldn't merely be a corporate triumph for a single startup, it would signal a tectonic shift in the very foundation of energy storage, proving that higher energy, density, faster charging, and vastly improved safety can be achieved simultaneously on a mass scale. However, even in that scenario, it would be a mistake to interpret QuantumScape's success as an outright failure for an industry titan like Tesla. The electric vehicle landscape isn't a narrow two-horse race. It's an immense global and multifaceted arena of continuous innovation where multiple technologies and strategies can coexist, evolve, and even cross-pollinate. The sheer scale and complexity of global electrification ensure that no single company, regardless of its breakthrough, can monopolize the entire solid-state battery market or dictate the industry's direction alone. Tesla, with its deeply entrenched manufacturing process, vertically integrated supply chain, and proven record of relentless innovation, remains a formidable force. Under Elon Musk's leadership, the company has consistently demonstrated a willingness to pivot, acquire promising startups, and invest aggressively in proprietary research to overcome technological hurdles. Tesla's extensive gigafactory network and its own ongoing, albeit secretive, battery development programs, such as its 4680 cell design and rumored internal solid-state research, mean it is far from a passive observer in this technological arms race. It's entirely possible that Tesla could quickly license complementary technology engineer a competing or even superior solid-state solution, or maybe leverage its massive economies of scale to make alternative battery chemistries more affordable and efficient. Furthermore, Tesla is not the only major player in this high-stakes game. Legacy automakers like Volkswagen, Toyota, and GM, along with battery specialists like CATL, LG Energy Solution, and Samsung SDI, are all pouring billions into advanced battery research, each one seeking their own path to next-generation power storage. This creates a dynamic, hyper-competitive environment where progress in one camp inevitably accelerates progress in others, whether that's through collaboration, competition, or even reverse engineering. So, the narrative isn't really one of simple displacement where QuantumScape wins and Tesla loses, but rather one of industry-wide evolution and disruption. The emergence of a viable solid-state battery would definitely raise the bar for the entire industry, forcing every manufacturer to accelerate their roadmaps and innovate more aggressively. Ultimately, the real winners of this intense technological competition are electric vehicle enthusiasts and consumers worldwide. This fierce rivalry drives the whole industry forward at a breakneck pace, paving the way for cleaner, faster, and more affordable electric mobility.